everyone. Good morning, good afternoon, good evening, wherever you are joining us from. Welcome to our second session on machine learning, paper writing, and reading clubs. And I believe you joined our session from the first day. On our first day, we talked about advanced integration of Gemini into integration of advanced Gemini on Google Workspace to be able to write research papers. So we started this series on Monday, and this is the second session today, which is Friday. And our speaker is here already. The energy when you join this session, comment where you are joining us from. Tell us your key takeaways. If you have any question, do well to drop it in the live session comments, and also all your questions will be attended to. So I know you might ask questions like why do we have machine learning, paper writing, and reading stuff? So it's to bring us together to discuss, to be able to answer the question. Research is the foundations for machine learning. Without research, you won't be able to discover new models. And at the end of this session, which is going to last for about 1 hour, and it's going to continue throughout next week and few days after next week. We have lineup speakers. We have lineup speakers for this event. So without any further ado, and wasting your time, we are going to jump in right there. So today we are going to look at NGR00T N1, an NVIDIA model on an open foundation model for generalist humanoid robots. So there are different ways we can use AI or understand how AI works in robot industry. And our speaker, Mario is a software and startup co-founder specializing in artificial intelligence in web and mobile. He was also recognized by AWS Accelerator. I mean, if I want to list out his certifications and qualifications, I'm not really going to stop. He also holds a master's in optimization and applied computation from UAM, and he has led over 10 AI and ML projects with global organizations as Seed Stars and Catapult Accelerators. So and he also has AI credentials in IBM, AWS, and MIT. So I'll be he's joining us rightly to um to have the session on writing research papers for humanoid robots. So welcome, Mr. Mario. Thank you very much for joining us.
Thank you very much for time, and thank you so much, Victor, for the
Okay,
space.
so
Really,
I would like you to tell me a bit about your background, how you were able to navigate, and I mean your background, your story is really insightful. It's really encouraging. So I would like you to say a few things about your story, about your journey, before we can jump ahead into the
absolutely.
session.
Absolutely. So let's say by 2017, when I was about to finish my bachelor's degree, I realized that there was something called linear programming and non-linear programming. It was really spectacular to see how to model math models so that they can optimize the reality. Okay, so I got fascinated by that, and I started to believe that if there were some math models that could do more things, then we can use it like a superpower and become like a superhero. So nowadays we can see a lot of math models that were developed into more advanced stuff, and nowadays they call it machine learning AI or Gen AI models, and we can see that all of them now they have a great impact into society. We can see that there is many AI models that can detect cancer, for example, or even translate from one language to another. And nowadays they can help you and assist us in the daily tasks. So every single whether it's degree certificate that I've been developing is such thing and kind of a strategy that I have been managing in order to whether develop or even learn more about this field. So I'm really excited to tell you more about today's article and so on.
Okay, thank you very much. So at this point, I'm going to go behind the stage. The floor is yours. You can share your experience with us on, humanoid robots. So you can present so I can add your slide here.
Okay.
All
Yeah,
right,
I can.
thank you.
Yes, my pleasure. So when it comes to first of all, uh, just to tell you a little bit of my current experience in robotics. I'm currently with the company called Hanson Robotics, as mentioned, Victor. Um, so over here, what I do is operating the robot and also doing research regarding multi-agent systems. So I'm just really curious about all the things related to robotics and AI, and that's why I got excited to seek a route N1 and got into this opportunity. So today we're going to check out um, about this article specifically. We're going to kind of read it as you saw. I made a little presentation. I'm going to share to you. So give me just a second. Ta-ta-ta. Okay. Okay, there you go. So let me just start with it. So as you know, the name of it is Groot N1, made this little uh, image as you're seeing, generated by Meta AI. But yeah, this I'm going to present you first of all this little video from NVIDIA so that you can be more knowledgeable of what it's about. Cool. So as you saw on here, this is the Isaac Root N1 in an overview. There are many things that they have told, but we will see them just in a little bit with more detail. So let me go through. So we're going to check how is all this article that they released. which, as was said, it was an open source model that they released, called Roden 1, an open foundation model for generalist humanoid robots. So, at the end of the day, what they try to do, first of all, as NVIDIA the company, they want to accelerate all the humanoid robot research and development by providing this customizable pre-trained model, so that all developers can for the post-train or on a specific task or embodiments. At the end of the day, this is going to faster everything, and especially trying to use NVIDIA's technology in order to do so. So, first of all, as you were probably listening or even reading during the video, there are some challenges in this era of robotics. The first thing is that they need versatile hardware in order to control everything within the robot, and the second thing is that they they need really large scale data in order to train the robot. So the vision of this is that they can have generalist robots so that they can reason in order to adapt quickly and perform a certain task in real world. So the thing here is that at the end of the day, since there is a lot of lack of data, because hiring people or using people and try to get all this data is really hard, and also it can cost a lot of resources, and they use also simulations of that, and there are a lot of techniques which we will be talking soon. So at the end of the day, they use it the omniverse, and also um, the other one, which we'll be talking soon, in order to generate even more simulations. So at the end of the day, trying to integrate different kind of data, which could be real or synthetical one, in other words, multiple data sources, they use it their own dual system architecture so that they can reach the perception and the action. In this case, which we'll be talking about, the vision and also what is doing the robot. So, first of all, um, what happened here inside this article, they try to introduce their vision language action model, because what they're doing is that they are visualizing what is happening when it comes to actions, labeling the actions, and then sharing in this dual system that they design. They have uh, two uh, two systems that they have, which in the first one they have something called vision language reasoning model, and the other called diffusion transformer, which is for the real-time motor control. At the end of the day, since they are trying to combine the vision and also the action, is called that they have cross embodiment support, so that they can have it from the tabletop to the humanoid robots side. Uh, we can say that at the end of the day, this is for high data efficiency and strong performance. So let me tell you more about this one. Uh, for the overview of this model, they try to have all the visual observations, language instructions, and robot state. And what does it mean? That mean that they are trying to label all these parts and try to prompt something specifically so that they can generate it. They are processing, as I was telling you, the part of the vision. They are trying to use the diffusion transformer for the motor actions, and so on. So a little diagram about this that they shared inside the article, as I was telling you. Um, this is the part of the vision where they have an image. They have a prompt over here, and they in this case encode with the tokens everything. This is when it comes to the image and when it comes to the prompt and so on. This is processed by a vision language models that we will see, which what is the backbone in a few minutes. And also we can see that there's a robotic state that it's trying to see, hey, what is happening with the joints, what is happening uh, with the arms, uh, with the legs and so on. Because probably the videos of robots that you have seen that been trained uh, by GR00T N1, probably they seem to be really natural. And it's because all the joints and all the positions that they have regarding is being encoded. So after everything from the vision language model is processed, we can see that robot stays encoded, they pass through a diffusion transformer. And as a result, we can see the final motor action. So at the end of the day, this is called dual system design and vision language action model. So I'm going to be really quickly on this. I already told you this. This tries to uh, gather all the multimodal inputs, such as images and the natural language instructions, so that it can understand what's happening in the environment and generate these high-level plans with some reasoning. And then it tries to fast think or try to reflect what is going to be the next action at the end of the day accordingly with the diffusion transformer. So at the end of the day, this model not only try to reason but also uh, try to plan and execute all these tasks accordingly with a human-like dexterity and responsiveness. Um, Trying to get even more into this model architecture, um, in the first system, this is well the system 2, the vision language model. They're using their own pre-trained model, Eagle 2, which is a vision language model that NVIDIA trained it by themselves. Um, so as was saying, they tokenize the image and text inputs, and then they embed everything. Once that everything goes well with the fusion, they go into the fusion transformer. Um, they use some techniques such as flow machine matching, so that it can iterate the noise and so on. Um, at the end of the day, they try to process the states and the actions and so on for embodiment specific encoders and decoders. So just giving you a little other diagram, and as I was saying, the Eagle 2 BLM is the one that they are using from their other previous research and so on. And as I was saying, they are trying to iterate the noise and so on with their own blocks and so on. Of the DIT is for diffusion transformer, so they try to iterate accordingly. As we are seeing here, they encode the state and they encode the actions of the robot and so on. We can see, going to try to go a little bit here. No, well, inside these blocks, we can see some cross attention and self attention blocks. Um, and also we can see at the end of the day that after this diffusion transformer blocks, it goes to an action decoder so that it can goes to the robots and do the actions accordingly. Um, so at the end of the day, we can see that this is part of the vision and language with what that comes with the cameras and also with a context, and also at the end of the day, the action data that refers to the continuous robots trajectory. Because it's training in cross-embodiment manner, we can see that it generalizes different robot platforms. Probably they have one hand or two hands, or probably they don't have even, I don't know, probably they don't have even legs. Maybe they have wheels. So at the end of the day, how they train all of this, how they make this possible? Because as I was saying, this is really quite a challenge uh, to gather all this data. So um, let's get into something called a train data pyramid. This concept is about to have three things: the base, middle, and top. As I was saying, it's a real pyramid. The base, they have data from the web and also egocentric human videos, and then they have middle data that are synthetic. which could be like the trajectories that they were generated by AI. So let's say that they put like an image and say, hey, generate me the sequence of images, or try to generate a video according to this image, so that they can have simulation of a trajectory. And at the end, also there are real world trajectories of the robots, or could be teleoperation within robots. Um, so let's see a little bit of this. This is more a graph of this one. Um, as I was saying, here's the real world data within robot simulations, which are also one of the things that I have to tell you is that when it comes to the simulations with synthetic data, it's not only generating new data, but also generating new conditions with new data. Because some of the things that we can see with the root blueprint is that they try to generate also scenarios that are quite different to the ones that were shared. And finally, the web data and human videos. So as you're seeing here, some of the simulations that were drawn this blueprint is that they use it about 780,000 synthetic trajectories for 11 hours. Um, I don't remember right now other metrics that I was reading inside the article, but they try to generate a lot of hours from just some images and videos. So this is really amazing because they try to generate something from almost nothing, let's say. So the ROI in this case is really amazing. So this is the data that they got, and how they train all of this. So they developed something called flow matching loss in order to train their own model accordingly with this dual system, and they try to integrate all this data, the latent actions, the simulated trajectory, and the neural trajectories. Because something is like, okay, where it's going, what was simulated, and okay, this is what the robot is doing accordingly. Okay, and once that it was pre-trained, then they try to post-train by fine-tuning the digital robot embodiments, because every single robot is quite different to each other, and then try to adapt the data efficiency according to the limit of human demonstrations. Because at the end of the day, we know that since every single robot is different, we need at least some demonstrations of how the robot should do it in some samples. Um, uh, the key techniques when it comes to this training, they extracted some latent actions via this model that they also train it with by so that it got the features. Um, as far as I remember, they try also to generate, as I say, some some videos with given an image and so on. And also they labeled several actions with a technique called inverse dynamics models, which is going to be real amazing to have this labeled. As we can see inside the image, they try to label actions. Um, in this case, to the move the right arm to the left, and also move the right arm to the right. Okay, this is just a really simple action example. Okay, over here we can see synthetic generated videos. As I was telling you, here's the first image, for example, that says pick up tools from mesh cup to clear bill, and then it generates the sequence of images and so on. Um, and one of the things is that once they are trying to post-train, they have to gather the data for the specific embodiment of the robot. They have to use some hardware specifically. In this case, they say, hey, you can use three options. You can use Manus Glove and the Vivo Ultimate Tracker. That's the first one. The second is the Apple Vision Pro, and the final is a Leap Motion. The two options that are below, the Apple Vision Pro and the Leap Motion are uh, deep cameras. Uh, they try to see what's happening in the vision side. Um, and this one, it tries to, well, with your own hands, try to be more accurate about what's happening, what's going on. I don't remember right now the prices, but yeah, I think the Leap Motion could be um, the cheaper one. Well, at the end of the day, they try to capture the human motion. They try to target it and try to simulate it so that they can have more data and so on. So as we saw in the video, they first will try to pre-train the data, then post-train the data, and something that was not told in the article, but this is going to happen also, is that they will do test time scaling, which is long thinking. So what's going on here is that at the end of the day, they will need even more data, even once the model is trained. So this is one of the things that is really amazing, that they will have test time scale, test time training. Sometimes they call it that, or inference training, training during inference. Okay, these are images. Oh, this is really good. This is a Groot blueprint. We saw that over here. We have the operator. They have a demonstration, and with the ISAC lab, they collect all these demonstrations. They annotate it with Groot Mimic. It passes through the ISAC lab. We can see here how is this then generated with more examples. Uh, with the physics engine, we can well, over here we can see this is the trajectory generation, the physics engine, and the trajectory evaluator, so that this could be accurate. And then it's generated with Isaac Sim and Cosmos. So it's really important to mention to you. Oh, sorry, that they use Omniverse to have um, this simulation space and Cosmos to generate all the possibilities to all the scenarios. As you can see, here's a little sample of video. So when it comes what comes to experimental setup and benchmarks, they use it different simulation benchmarks, 3 in total: RoboCasa Kitchen, Text Mimic Gen Cross Involvement Suite, and GR1 tabletop tasks. Um, the first one is more for atomic manipulation tasks. The second one is more for both manual detectors tasks, and the final one is for more dexterous hand control. At the end of the day, since they are using simulations um, to make this happen, these simulations benchmarks are the greatest that they found. And what happens then to the real world evaluations? They try to do some samples. Um, they mention a tree in this case, object to container, which is pick and place, articulated and industrial object manipulation, and finally multi-agent coordination tasks. And what it means multi-agent coordination tasks is not as we have heard about agentic AI. Um, it's more it's more about, hey, we have a robot, and then which has a role which will perform a certain tasks, and then it will share later once it's finished with its task, the further object that he has processed. So that's why in the final video, uh, in the video that we saw, they have two robots doing two things because they are coordinated in order to perform a final procedure and so on. So at the end of the day, the evaluation protocols, they had to make like multiple trials, and they also compared with some baselines with some transformer and also the diffusion policy. Um, at the end of the day, the end root, the Groot N1, it really shows a superior success rate, and also it really has a really strong performance with the human, with only 10% of human teleoperation data. What does that mean? That means that even though that if they try to compare the benchmarks with the uh, base models, which is transformer diffusion policy, with really scarce of data, 10%, it is showing that it has like a lot of predominance here, a lot of dominance even in and of lack of data. Um, what is the kind of simulation tasks that they perform? Uh, as you're seeing in the screen, we can see that they try to pick and place, they try to turn off stove, set up the mug, pouring, grab coffee, grab a cup of the drawer. So many tasks that they try to perform. So it's really important for you is if it's your, let's say, um, wish to train your own, let's say, robot, try to gather all this information. I'm going to share later this presentation, so don't worry, and also the GitHub repository where you can download the model. But yeah, definitely, at least you have to have whether it's your Leap Motion controller, your Apple Vision Pro, or the other one that was mentioned, so that you can try to make many of these simulation tasks and try to use the Omni the Groot blueprint. Oh, so as I was saying, the simulation task within the benchmarks that I mentioned, RoboCasa, DexMNG, GR1, um, Groot N1 surpasses by them almost like 15% in average. Um, and one of the things when it comes to the real world scenarios, uh, it was said that with at least 10% of data, it surpasses almost every other benchmark of the diffusion policy. As we are seeing here, um, with a full data diffusion policy, for example, is 36% uh, of accuracy, and with the 10% of the gluten one is 35. So we are seeing a lot of dominance here, um, and we are seeing that in average it has like a really great advances and strong results. Other things related to neural trajectory ablations, we can see um, over here the success rates, and we can see the gluten one really surpasses the other model of diffusion policy and so on, even in the real year one humanoid that they tried. So other things that they have when it comes to the behavioral observations is that they can have the manual coordination, and that means that they use the both arms. Okay, so because sometimes it's really difficult to manage only one output, they manage it with their group and want to coordinate accordingly, and that's one of the amazing things that this really model can do. Really amazing model they can do. So that means which uh, that that means that it has like really smoother actions, which could be like human-like actions. Okay, I try to be as accurate as possible. That's why it was mentioned at this case study. Pick up the red apple and place it in the basket. So as you can see in this image below, we can see how it tries to manage this little apple. Here's another one, which is with a cross-training qualitative example. Pick up lemon from cutting board to the basket. Okay, pick it up cucumber from placemat to the baskets and so on. So we can see that they try to use the group N1, the diffusion policy model, and so on. And at the end of the day, group N1 wins. So we have already seen that this model has really great progress, results, and a lot to give to society. But the limitation here is that it's focused only on short horizon tabletop tasks, which means that they only, if we prompt something or label it and so on, they are only focused on something specific. So they, let's say, if we were talking like about like an I don't know, like the ChatGPT o1, let's say, compared to the ChatGPT 4.0, we could say like Groot N1 is like ChatGPT 4.0. Okay, it's like the base model that try to do really specific tasks and so on, but they don't try to reason when it comes to long horizon local manipulation tasks. What does that mean? That means that they try to get something done when it comes to on a specific tasks. Okay, that's why it was really important to have this multi-agentic coordination. So I believe that, at least from my perspective, that they'll try to probably generate something like a reasoning root um, whole one model, for giving an example. Uh, so as I was saying, always the limitation will be the data when it comes to the quality and diversity. So I believe that there will be more um, techniques, more than the ones that I have just mentioned to you. Probably they will improve, as I mentioned, the spatial reasoning, explore more novel architectures, augment the data, and have more tasks in this case that could improve the model. So at the end of the day, Grid N1 offers this unified and dual system approach for all the generalist humanoid robots. It has already shown a really strong generalization and data efficiency across all these diverse tasks. Uh, it has really a really really great cross embodiment system. Um, they they really show it really great things when it comes to data augmentation, from having a teleoperator try to get some data, then have the root blueprint and try to show how to generate even more data. And the most important thing is that they are open source model. They share the training data, they share their simulation environments, and I try to accelerate all this, deploying generally capable human robots in the real world. So, in case that you're really interested, I really encourage you to go further with the research and try to collaborate with this Grid N1 framework. But hey, before we finish, what about the robot, the blue robot? Okay. Mhm. Wow. Hmm. So just wanted to show you pretty quickly about this little robot, which is called Newton. They demonstrated that they cooperated um, with Disney Research and also Google DeepMind, because the most important thing, as one of the things mentioned earlier, is the hard part is also the hardware, because they have to really simulate all the things when it comes to the physical engine, because having a physical engine that could where you can train all your synthetic data, that's going to be really important. So they show it a really smooth robot that was like from a Star Wars. So at the end of the day, um, this Newton robot and the models and so on, is is an open source extensible physics engine, so that you can take a look, and I'll show you this also presentation. It was built in something called the NVIDIA Warp, so that they can learn the complex tasks and so on. And this Newton is compatible with the learning frameworks such as Mujoko Playground and the Isaac Lab. So at the end of the day, this is open source, unified for framework for robot learning. So um, at the end of the day, giving all this information, I know this is quite a lot. We have seen that we have to have really good uh, data in order to train or for our own robot with the GR00T N1. So we have to have really good multi-embodiment settings and so on. Uh, and the thing here is that gonna be quite difficult sometimes because of the devices and the time. But if it really works it, so you have real world data that you can generate, do it, and then try to generate it with this GR00T blueprint. And potentially, as I was saying, probably GR00T N1 not not going to be developed for other tasks, but I think that it will be like a reasoning model, at least from a perspective, like ChatGPT 4.0 to ChatGPT 0.1. There will be probably something like root 0.1. So that's all, everything that I have to say for the moment. And well, let's get into the questions and answers. Oh, hi, Victor. Can you are you there? Hi, Victor. Are you there? Oh, I cannot hear you.
Yeah, so thank you very much for the session. And we have talked about a lot of things, practical hands-on on how these systems actually evolve and how they are being used today from the humanoid robot standpoint. And I just want to ask a few questions. So, from your practical knowledge, the future of artificial intelligence
Uh-huh.
in the areas of humanoid robots, and what can you say are the things can be done to research papers?
Sorry, can you repeat the question? I heard you like a little bit.
Can you hear me? Can you hear me?
Yeah, can you repeat the question, please?
Did you hear my question?
Oh, can you repeat your question, please? Or can you
Okay,
write it?
so I said what would you say, or what can you what are your recommendations on how, talking about the applications of artificial intelligence in the field of humanoid robots? What can you say are the things we can improve to be able to drive research, to be able to drive research in the um, from the perspective of applying this to in building autonomous systems that solely depend on AI driven decisions.
Okay. So I believe that there is a really big opportunity when it comes to, let's say, train your own robot. I believe that there will be some job opportunities on being like a robot trainer in some cases, where at least like try to gather all the robot data as possible for a certain prototype, or even trying to generate all other kind of, let's say, architectures. And as I was saying, almost in my conclusion and discussion, the thing here is that there is a kind of opportunity to make long horizon tasks with a reasoning model of the root N1 model, something like a root O1 model. So from my perspective, trying to generate data from a specific robot, or trying to generate data for other specific tasks that could be for the household chores, or even other things that could be for daily use of the human, that could be like related to the industry, like, hey, let's say assemble a car by Ethan, or let's assemble the robots itself. Why not? So trying to check the some other use cases, because I'm just sharing these ones. So at the end of the day, this is more for the dynamics of the robots, how to move it. Probably in the future, we will see some robots that could train with other humans for sports. I don't know, probably table tennis, or maybe something like karate, or even taekwondo. We're seeing this for sports that could be like the most dynamic and specific things, you know. And finally, I guess that a combination of that with some social AI, that will be the best. In my experience, I'm more into social AI, and try to see how is the behavior when we get with multi-agent systems that try to gather information from the background, and try to make something really specific and consciousness as possible. So I think that at the end of the day, uh, they are making really good synergies with the correct companies. Disney, for example, and and DeepMind, they are like the core of all AI, I believe, and also the part of entertainment, that they'll try to see how to make this happen, and also profitable at the end of the day. So I guess that sticking mine in some other research when it comes to how to get into sports, how to get this combined and merged with social AI, and also how to generate more data or reason the model even more further. Just try to do it. So I'll share you just the link, so that later you can check it, and also the others. Um, and in any case that you want anything from my site, my email is Mario Rot, TCUN at gmail.com. Um, you can find me also on LinkedIn, like Mario Rodriguez. And well, really happy to answer any question. Cool.
Thank you very much for answering that question. So also, if you are watching us and you have any question or contribution, feel free to drop your question in the chat section. We are going to attend to it, and we are going to answer all of your questions. You know, I am actually always interested in building robots. I think most of the challenge I do have is usually the cost. And so let me ask one more last question. So in this instance, okay, most of the robots that okay, from building an artificial intelligence based robot, does it require GPUs embedded into like the hardware components of the robots to be able to build an autonomous system. So if I'm saying a robot, what I actually I know we have different forms of robots, but what I actually have or what I actually mean is a kind of this humanoid robots that can think and then um, mimic some human behavior. Do we actually always need to embed GPUs inside the hardware, or it's solely on the architecture of the robots?
Well, at least for the dual system in this specific article, the system 2, which is the vision model for the pre-trained vision language model, they run at 10 hertz an NVIDIA L40 GPU. So if you try, well, I think they try to use that kind of GPU, uh, but it's going to be important to go to the specifics inside the article and try to see. At the end of the day, for at least for the GR00T N1, if you want to take a look on that, you have to use yes or yes more kind of GPUs at least for the system too. Um, that's what that's one when it comes to the article itself. Uh, there are other things also, but that's the main one. Okay. Possibly when it comes to the training cluster, that could you should they I think they train it with some H100 NVIDIA GPUs connected with some NVIDIA Quantum 2 Infinity Band. Um, so they use that to train the infrastructure. Um, but that's one thing. Um, that's the only thing that I could say when it comes to the training and so on. Um, and one thing is that for uh, NVIDIA GR00T N1 model, I think they use like 1024 GPUs for a single model. Uh, so at the end of the day, what I could tell you for the GR00T N1 2B, they used about 50,000 H100 GPU hours for pre-training only. So really amazing use of GPUs for everything. Um, but I think that is only for pre-training. That doesn't mean that they will have to use um, you have to use that for post-training when you download the GitHub repository. That's going to be quite different, and that will depend more on you. I'm going to share you the link of also the GitHub repository so that you can take a look on the Isaac root model and try to see if you like to uh, fine tune it in some way.
Okay, so thank you very much for joining us today for hosting this session. And
Yes,
I'm
my,
going
my
to,
pleasure, mate.
after the session is here live on YouTube. After now, you can still share the link so that other people can watch the session live. And we have our next speaker that is going to continue the session next week from Monday. So you guys have the session Monday, Wednesday, and Friday. So wherever you are joining us from, feel free to share the link and share with your community as well. So since you don't have any other question, I'll say thank you very much. Really appreciate this opportunity and coming to share your knowledge with us. Thank you very much. And I have the links to everything we have shared. I'm going to, okay, I think we have a question here. Hi, okay, okay, we have a question actually, so I'll just go through it. So the question is, hi, I'm Sam. I am an architect, graphics designer, and a technical enthusiast. The session is informative, right? My question is, what opportunities are there in robotics for those not into programming? So he's asking question about the
Well,
opportunities for those in yeah, opportunities. What opportunities are there in robotics for those not in programming? So this person is like has no programming skills. What are the opportunities?
yeah. So gonna be pretty quickly because I'm about a minute to enter the meeting. So over here, when it comes to job opportunities, I believe that something that is not programming could be generating data. That's which means like trying to teleoperate the robot and try to gather that information from a specific prototype of robot. That will be the first one. Um, what are the things that I could tell you? So something that is not programming is hardware. Trying to make hardware within the robot, that will be really amazing. Um, other thing that I could tell you. Oh, probably try to make some um, multi-agent systems when it comes to social AI, so that you can try to use a tool called NAN. I'm going to share it here. It's a low-code tool. You have almost tried to use it. Okay, you, that will be my suggestion. Try to use it and so on. So that's that's my suggestion for somebody that doesn't know programming. Uh, this this tool is very intuitive. You can see some YouTube tutorials. So thank you so much for the time. Sorry right now, Victor, but I'm running out of time. I have to go to another meeting. Um, thank you so much, and I'll see you soon. Really appreciate your time.
Okay, thank you very much. So thank you very much. And Sam, I believe your question has been answered. Well, you can, if you have more questions, you can drop it here or reach out to us in any of our community channels. Thank you very much, Mario, for having a great session with us. Thank you.
Sure. Take care.